since I can't sleep right now, let's just do some math, and maybe this will help someone. Um, uh, the whole purpose of this channel, it will be all about sharing my love side for science. I'll be sharing certain courses, and since I can't sleep right now, and it's like 4 in the morning, and I love math, and I chose to just start with math. Other stuff will come later. But right now, uh, I feel like I should start with one of my favorite class, which is calculus. So since I didn't have time to prepare for Cal 1, let's start with calculus 2, because when I was looking through the books and stuff, that's the stuff that I found as quickly as possible. So let's start with some formulas that you need to memorize before we start, because this will be very important. It will also be time consuming. I mean, it'll save you time, because if you're taking a quiz or you're about to take an exam and you have not memorized these, you have to suffer. You suffer because they are very important. So let's start with derivative formulas, and then after that, we just do some antiderivative formulas that you may encounter during the exam. All right? So first one will be the derivative x to the n, and this becomes, so you bring the n to the front, and then you apply the power rule. This is called the power rule. So you gotta memorize that one. Second one will be the derivative of sine of ax. This would be turned into cosine of ax. The derivative of cosine of ax, which always has a negative sign. So basically what this means, if I was to give you an example right here, so if this was like, if you were trying to find the derivative of sine of, let's say, 2x, and this is the conventional way of writing the derivative, you just write 2 to the front, and then it will be cosine of 2x. Basically, this is what they're saying. And you get the idea for this down here, so it's the same idea. Next one would be the derivative of tangent of ax, which becomes secant square of ax. Derivative of cotangent of ax, which turns into negative cosecant squared of ax. These you gotta memorize, because if you don't memorize these, you'll be wasting your time during the exam, and the time that you should be focusing on harder questions. And this turns into secant of ax times tangent of ax. And the derivative of cosecant of ax times negative cosecant of ax times cotangent of ax. So now we move on to the inverse functions. You'll find the derivative of inverse functions. Some of them might be harder than these, but most of them you can just memorize all these and you'll be fine. My handwriting is horrible. I don't know. This morning I can't even write well. And the derivative of arctan of x over a turns into a over a squared plus x squared. And the derivative of arcsecant of x over a. I believe arcsecant has an absolute value, but I'm not sure. And we'll just write it like that. It turns into x, and then the radical sign, x squared minus a squared. All right. That was arcsine. Now we move on to the derivative with respect to x of ax to the natural log of a times a to the x. Derivative of e to the ax turns into a natural log of a. I believe that's not correct. I believe this will turn into, so you bring a to the front and then e to the ax. I'm not going into details about explaining all these and why they are the way they are. I just wanna, like I said, I can't sleep. I just wanna start with all these stuff. I want you guys to memorize so that it'll be easier later on. And the derivative of ln of x is always 1 to the x. And I think these will be the ones that I can remember from my head. Maybe we can just, let's see. Maybe we can just do the antiderivatives a little bit. Or the integrals. And I believe those, it's a lot of them. If I can't remember, hopefully I can remember like 20 or something. I don't know. So the integral, let's start the integral of sine of ax dx. This turns into 1 over a. For the antiderivative, if you have sine right here, it's a positive sign, but for the integral, you have to use a negative sign right here. And then it becomes cosine of ax plus constant e. When you have, with this constant, for this constant, when you have definite integrals, let me write, for definite integrals, this constant can be, you can just say it's 0. But these are not definite, so they are indefinite integrals, so you have to write it there. You have to put it there. All right. Let's see. Let's go move on to cosine, the integral of cosine of ax dx, which will turn into 1 over a sine of ax plus c. C is just a constant. All right. So, and then we can move on to maybe tangent, the integral of tangent of ax dx. So tangent, the integral of tangent, it would be natural log of secant of x plus c. The integral of secant of ax dx. This would be natural log of absolute value of secant of x. Secant of x plus tangent of x plus c. All right, let's keep going for the stuff I want you guys to memorize. Then it'll be the integral of x plus a dx. And it's returning to the natural log of x plus a plus that constant. And we can move on to maybe cosecant, natural log of cosecant of x dx, which will turn into natural log of absolute value of cosecant of x minus cotangent of x plus c. Man, I didn't know these were going to be a lot of them. It's a lot of them. What else? It's natural log of, the integral of x to the n dx. This would be, so we had to apply the power rule, so this would be x to the n plus 1 divided by n plus 1 plus c. And then you can find the derivative of 1 to the x. No, that's not correct. 1 plus x squared dx equals the arctan of x plus c. Number 10, the integral of cotangent. Let me make sure I'm not repeating some stuff. Cotangent of x dx, which will turn into the natural log of absolute value of sine of x plus c. Cosecant. Okay, let's see. Number 11, you can find the absolute value of cosecant. The integral of cos. I don't know what I'm saying. I don't know if it's because I'm tired and it's in the middle of the night and I can't sleep. I'm just saying weird stuff. But anyway, we'll be okay. We're almost there. This will turn into the negative cosecant of x plus c. All right. And the integral of secant of x times tangent of x dx. This will turn into secant of x plus c. I'm almost there, just bear with me. And the integral of secant square of x dx will turn into tangent of x plus c. Okay. The integral of 1 over x dx. This turns into the natural log of x plus c. Okay, we got a few more left, and then we can just stop from there, and we can call it a day. And once we start going into details and we start doing some fun stuff, that's when you see how important these are. You gotta memorize them. Use flashcards or something. Memorize all these so that it'll be easier when we are going into more details. Okay. So we got like three more, and then we'll be done. The integral of 1 over x and x squared minus 1 dx equals arcsecant of x plus c. If you look at all these, and then you go back there and look at these, they almost look like they're the antiderivative of this stuff right here. So if you pay attention, that's what we're doing, right? Okay, so that's where we are. Let's see. Did I have the cosecant square? No, it doesn't look like I do. All right. So the integral of cosecant squared of x dx, it should be negative cotangent of x plus c, and then the integral of e to the ax dx, this will turn into 1 over a e to the ax plus c. Okay, and then the last one be the integral of a to the x dx, it should turn into a to the x natural log of a plus c. And these are the ones I can remember so far. And once I remember more, I'll be adding them on, or once we start solving problems and doing real exercise and working real problems, I may remember some stuff and some may come up, and then we add them to this. But these are handy. You gotta memorize these so that it make it easy. It'll be easier for you to solve problems, and you won't waste time. So anyway, thanks for your time. I hope I'll see you later. All right, bye.